Today we're beginning Unit 3, which is transformations in the coordinate plane. Transformations is when you move your graph or your image in your graph left, right. You could reflect it, you could rotate it, or you could make it larger or smaller. Throughout this unit, we have a lesson on each one of those things I just explained. Today's lesson is specifically on rigid motion and translations. So translations include shifting your graph or shifting your object left or right on the coordinate plane, up or down on the coordinate plane. Two very important vocab words that we use all unit are pre-image and image, and this is how I refer to every graph. So the pre-image is the original figure prior to or before any transformation happens. So this is the original figure. Transformations that could happen to the original figure include translations, reflections, rotations, and dilations. An image is the result of the transformation. So in other words, it's your final answer. I'm going to say final graph because that's what we're actually doing. So once you do your transformations, your final graph or your final answer is called the image. We're going to begin today's lesson with rigid motion for our first set of examples. And rigid motion is a transformation that preserves distance and angle measure. So if I was to break this down to more basic terms and explain it to you without using those fancy vocab words, I would say that a rigid motion moves a figure without changing its size or shape. So if a figure is transformed on your paper without changing what the shape is or what the size is, then it is called a rigid motion. For our first set of examples, we are determining whether a rigid motion occurs from the pre-image to the image. And I did label these for you just so we could talk about what we're dealing with. If we look at number 1, you can see that this figure is called the pre-image, and the reason why I know that it's called a pre-image is because, well, I labeled it for you, but also because take a look at the letters. So here you just see a letter M. Here you see a letter M with an apostrophe. We call this M primed. And we specifically use prime notation to indicate that we transformed the pre-image into the image. So notice in the future, notice this notation. If you see just the regular letter from the alphabet versus the letter plus the prime symbol, those are the indications of which is your pre-image versus your image. Okay, so besides the notation and besides the labeling of the pre-image and the image, just think to yourself, based on what you see here, did the size or shape of this triangle change, or did it just move on the paper? So hopefully you would all agree that it just moves on the paper. If I could try to show you that, let me use a highlighter. We have this figure here. I don't think I can turn a figure actually. So this figure just went and moved down here. I know I'm completely changing this, but just to explain to you. The size or shape did not change, it just rotated on my paper. So that is what happened here. I would say that this is a rigid motion. The transformation does not change the shape or size. Okay, and for these types of problems, I'm not going to try to trick you by changing the size just a tiny bit. If there's a difference in the size or the shape, you're going to notice it. If you look at number 2, you can clearly see that your pre-image is drastically smaller than your image. So that's what I'm talking about here. You're going to have a noticeable difference between the pre-image and the image if you're asked to identify a rigid motion. Okay, so focusing on number 2, we have our pre-image, we have our image. Also, just want to highlight that your pre-image has the regular letter from your alphabet, whereas the image or the new figure is the letter plus the prime symbol, which looks like an apostrophe. And that goes for all of the points on your figure. So keep that in mind for future problems. I did already use this one as an example to explain number 1, but hopefully you can clearly see that the pre-image is smaller than the image, so we would say this is not a rigid motion. The transformation changes the size of the figure. And right at the bottom of your page, I have a note typed out for you. This actually just explains what I've been talking about with the prime notation. So this note says, a transformation maps every point of a figure onto its image and may be described with an arrow notation. I'll talk about that in a moment. And also prime notation. This is sometimes used to identify image points. So in the diagram below, K prime is the image of K. Again, we did talk about this a little bit. I am going to explain it further. If you are using the correct notation, here is our pre-image. Here is our image. I know this because I'm looking at the letters K and then K prime. Also, you have to be very specific when you are writing out the notation. So this triangle here maps onto this triangle here. And when we write our notation, we are going to write this as triangle JKQ using a triangle symbol. And then we're going to use an arrow. It maps onto triangle J prime, K prime, Q prime. And I'm going to write out how I would read this. I would read this as triangle J, K, Q maps onto, that's the arrow, so the arrow reads as maps onto, triangle J prime, K prime, Q prime. And that's how you would read this notation. So I'm explaining the notation here. You'll get used to it, or you'll get used to seeing it once we start some more examples on the coordinate plane. But you are expected to recognize the correct notation, and you're expected to use it throughout this whole unit. So I'm explaining it here, and you need to pay closer attention once we go through the examples, and then you are expected to use it. Okay, here's a note like we've been talking about. So J prime is the image of J. We would use prime notation to indicate this. And then I made another note just because sometimes you'll see this. You could also use a completely different name or letter depending on the example or the diagram provided. And you'll see some more of this as we go through the notes as well. Okay, the next section is an on your own section. So I'd like everyone to pause their video and try your best to complete the on your own section. Once you have your answers, please come back to the video and compare your answers to mine. Now we're on to translations. Translations is the first transformation in the coordinate plane that we will be learning about. Translations do hold the definition of a rigid motion. Not all transformations do, but translations are one of them. Which means that when we transfer our shape or translate our shape in the coordinate plane, we are not changing its shape or size. We are physically just moving it left, right, up, or down. So a translation is a transformation that maps all points of a figure the same distance in the same direction. So for the example that I gave you in this box, the translation rule is written as this, and you need to make sure you are writing it in the same way. So this is telling you that your original point x comma y the arrow is telling you maps onto, and this here is telling you that you add 4 points to your x value of the point. So it's telling you that it's a horizontal shift to the right 4 units. And this here is telling you that you have a vertical shift, and in this case, because you're subtracting, it's telling you to move down 2. So just to read through this again, this says x comma y maps onto x plus 4 comma y minus 2. Now let's look at the graph. Let's take a look at point A. Point A starts at this location, which is at -3, +3. Point A to A prime shifts over 1, 2, 3, 4 units, and then it shifts down 2 units to get to A prime. This example is already completed for you. So let's move down to the example here and let's complete this one together. So for this one, I'm going to show you how to fill in a table just so you can make sense of the numbers. But once you do just 1 or 2 of these, you're probably going to be able to move the transformation right in the coordinate plane without making a table, and that will definitely save you some time. So when I move on to the on your own section at the end of this, you will see that I just count in the coordinate plane. So anyways, this example here says to find the image of XYZ under the translation, and there's the notation that we're looking at. So x comma y maps onto x minus 3 comma y minus 2. So what we're going to do for the first problem, for this problem here, is I'm going to pull the points off the coordinate plane. We're going to go in ABC order, so starting at x. X is at the location of 3, 3, 5. So x comma y is at 3, comma 5. All right, 3, comma 5 maps onto, so your x coordinate, we have 3 and then minus 3, comma, our y coordinate, which is in this case 5, minus 2. I am going to simplify this, and 3 minus 3 is going to be 0. 5 minus 2 is going to be 3. So I know that my x prime point is at 0, comma 3. Now I'm going to come back over to my graph and I'm just going to explain that shift for you. So this point is, or the new point, x prime is going to be at 0, up 3. Now what we could have done was we could have taken our original point. You always do your horizontal shift first. Because we are subtracting 3, we are going to move over 3 units, and we are going to move down 2 units. So we could have just counted in the coordinate plane to get us right to that location, and that's what I would suggest you do. But a table might work for you as well. All right, so I just moved x to x prime. Now I am going to do y, which is currently at 0, comma 2. When I apply my transformation rule, my x coordinate of 0, minus 3, and I have my y coordinate of 2, minus 2. When I simplify this, 0 minus 3 is negative 3, and 2 minus 2 is 0. So y prime, my new y coordinate, is at negative 3, comma 0. I'm going to come over to my graph. I'm going to go over to negative 3, down 0, plot a new point. Going to label this as y prime. Again, we could have just shifted this graph over 3 units, down 2 units. And for the last point, we're looking at point Z, which is currently at the location of 2, 4. Oh, I said that backwards, 4, 2. So when we apply our transformation rule, we have our x coordinate of 4, minus 3. We have our y coordinate of 2, minus 2. 4 minus 3 is 1. And 2 minus 2 is 0. So our new z coordinate is at 1, comma 0. I'm going to come over to my graph and I'm going to plot my new z prime point at 1, comma 0. We could have just shifted this 3 units and down 2 units. So it's up to you whether you want to make a table and do out the actual math, or if you want to just use the coordinate plane and actually count. Whatever is best for you. So once you have your new points, you have your primed points, you're going to connect them to make your new figure. And this here is going to be our final answer. I'll just shade this in so you can see it. That is the transformation of our original graph. Now, if I was to shift this graph, hold on one second. If I was to shift this, I can show you that it's exactly the same as what the original graph was. So here's our original graph. we shifted 1, 2, 3 units to the left, and we shifted 1, 2 units down. That gives us where our final graph is, and that is what a translation in the coordinate plane is. Again, you just have to be very careful. If you're subtracting from your x value, you are shifting to the left, which you should notice because of what you're doing with your values. If you are adding to your x value, you are shifting to the right. If you are subtracting your y value, you are moving down. If you are adding to your y value, you are moving up. Think of your x and y axis both as number lines for problems like these. Okay, again, please press pause on your video. I want you to try the on your own section by yourself. Once you have completed it and have answers, come back to the video and go over mine, compare your answers to my answers. If you have any questions, please let me know.